Hello. What I'm hearing the claim that you could block out the entire moon by holding a dime at arm's length. So recently, I decided to see if that's true by determining the minimum radius that an object needs to be such that when held at arm's length, it blocks out the entire moon exactly. And this is pretty simple. So we're going to draw this diagram where this is your eyes. This is a coin diameter, coin diameter, and then this is the moon diameter. As in the diameter across its surface, like from Earth. So we're gonna make this easier for ourselves, and we're going to split this in half. So then we have this right triangle. So this is going to be the coin's radius because we split the diameter in half. So RC. This is going to be the moon's radius because we split the moon's diameter in half. RM. And so then we're going to have this side from the coin to your eyes be little d, which is your arm's length. Distance, this is little d. And then from the coin to the moon, we're going to call big D, which is the moon's radius, the moon's orbital radius, like the radius of the moon's orbit around Earth, minus your arm's length. So then we're going to call that big D, and we're going to write up here, big D equals moon orbital radius minus little d. So just so we remember, these are similar triangles. There's a formula for the ratio between these four variables, and you can look it up if you want, because this video is not about similar triangles. It just happens to involve the formula. So we get our moon divided by RC equals D plus D, big D, divided by little d. And since we already called big D the moon's orbital radius, we're going to sub in for the moon's orbital radius, and let's call the moon's orbital radius big RM. So then that would make this D plus D would be D plus moon's orbital radius minus D. So just moon's orbital radius, because those cancel out. So then big R M divided by D. And then we're going to solve for RC because we want to know the radius of the coin, because all these other things are knowns. So I will let me use my double-sided arrow drawing here. Here we go. So we're going to cross multiply. So RC times RM equals, RC times big RM equals little rm times D. And then we would just divide by big RM to get that RC equals little rm times D divided by big R M. So now we need to know all these facts and figures, which I've helpfully written down for us. So first off, little d, arm's length, equals 76.74 centimeters. I got that figure from a study done on high school students in Addis Ababa, Ethiopia. I couldn't find any other studies directly measuring arm length. I could only find arm span, And arm span is from fingertip to fingertip, which does not, like, that has no bearing on arm length because then you have your chest in the way. You can't just divide by 2 because then you're getting this segment, and then it's just, that's just, starts to make no sense. But I found this one. So this is probably not the general arm length, but I mean, I assume that the high school senior in Ethiopia is not a standard for like all humans, but close enough, right? So big D is, sorry, not big D. Big R M is 3,000 or 384,399 kilometers. And then little rm, radius of the moon, is 1,737.5 kilometers. Mind you that the radius of the moon in 3D space from its center to its edge is going to be the same as the splitting in half of our apparent view of the moon. And you can think about that like this. Here's the moon. If I draw a line from edge to, or from center to edge, notice how it also just directly cuts in half the moon in the 2D plane. So it's the same as the radius in the 2D plane. So it works out. Plugging all this in, and also adjusting, our units, obviously. I put them all in meters because that's the best unit. I say that, I'm about to put something in centimeters. I got 0.00346 meters, which is equal to 0.346 centimeters. Okay. Now, I do not have the exact figure for the radius of a dime, but I am pretty sure last night when I looked it up, I got 0.00855 meters. And if I'm wrong, I'll correct myself in the comments. But this is the radius of the dime. And you'll notice that that is bigger than the minimum radius that we need, meaning that a dime can block out the moon entirely. And so then I was like, oh, well, cool. What other coins could block out the moon entirely? What's the smallest one I can get? And then I remember that the dime is the smallest coin. So that's kind of, a little depressing. But let's make a general formula, because this isn't very satisfying. The moon's orbit is not a constant thing. It's not always 384,399 meters, or kilometers, sorry. It actually varies by day. As you know, there's the moon's apogee and perigee, so that moon looks bigger and smaller in the sky sometimes. So let's make a general formula for this. So the one I came up with, and I'm not sure if it's accurate or not, for the radius of the moon's orbit, big R M of D. And by the way, in this equation, D is days since the moon's last apogee. Apogee meaning it's the farthest away it can get. So days since it was the farthest away it can get. Like if it happened today, I'd put 0 in this. Equals 384,399 plus 21,100 times cosine of 2 pi divided by 27 times d. And this is kind of accurate. And I saw something online that was similar to this when I looked it up, but that was AI overview, and it said something about goth. And so I don't know if I don't know how I feel about that. But this is what I came up with, and it's somewhat accurate. And I came up with this, and once I looked up, I was just gonna try to find the formula somewhere. I looked it up, saw something similar to this on golf, and I was like, I'll just try and derive it on my own. And this looks similar to what I saw online. So there you go. So plugging this all in, the radius that a coin needs to be, R coin depending on your arm length, which I'm not calling little l because I used d for day since last apogee. Little l, comma, d equals 384,399 plus 21100 times cosine 2 pi divided by 27d times little l, and then all divided by, wait, this is wrong. I'm so sorry, but I'm too far into this video to restart, so I just realized that there's a horrible issue with this. It should be 1,737.5 times L divided by, oh, I hate this won't be even, divided by 3,884, 399 plus 21100 times cosine 2 pi divided by 27d. That's what that should be. There's big R's on the bottom, and I mixed them up on the paper I wrote. But, so then, plug in your arm length. You plug in D for March 4th, which is the current day. D would be 22. And my arm length, I haven't measured yet, but later today I'm going to head by the physics lab and take a meter stick and measure my arm length. And last night, well, technically this morning at 1 a.m., I measured, I held up a dime and a penny and a quarter next to the moon. So you can see, I took photos. So I will show after this my calculations for my arm length and everything. And then also my how happy I am with it. A video of how happy I am with it. So yeah. See you in a second. Hello. So this is the section where I will be showing my stats, like my arm length and stuff, which should appear right here. And then the photos that I took this morning at 1 a.m. Of me holding a penny, a dime, and a quarter up against the moon should appear right here. They should have already appeared, actually. And as you can see, they look pretty good. The dime looks about, like, I would say it looks about 2 times bigger than the moon was in a photo, about very roughly, which is what we estimated it would be. Much like in the actual video that I just showed you, where this is 3.3 centimeters, so 0.003 meters compared to 0.008. So about 2 times the size is what the corn should be compared to the moon, which we see here. So hindsight, the dime's radius is 0.8 or 0.00895 and not 0.00855. And I feel like now that it's even so close to 0.009 and we had something so close to 0.003, I'm thinking maybe it actually, and looking at the photos again, the dime is closer to 3 times the size of the moon. Also, after this, I realized that when I saw this fact that Vsauce said, I don't know in what video he said it, but when I saw this fact, I do not think that Vsauce meant exactly covering the moon. I think he just meant that you could cover the moon with even just a dime held at arm's length. And because it's just showing how small the moon is in the sky is what he was doing that fact for. And so I think it actually makes it even more impressive that you could cover the moon with an even smaller coin if we had one. I think we had the Trime, which I think is smaller than the dime in the 1800s, in the Wild West, which we discontinued partly for being so annoying. I remember I got that from a CGP Grey video about like death to pennies, or it was death to nickels now. But yeah, if you like this type of content, like random math stuff. I post a lot of it. I also post puzzles and literature and crosswords and a lot of music stuff. So if you enjoy it, please like and subscribe because I like to talk to people about this stuff and it'd be nice to do so. But if you don't want to subscribe, that's fine. This is just a record keeping channel, so I'm not gonna upload according to what people are asking me to upload, unfortunately. But have a good day.